Hello everyone. As a part of aptitude training, today we will see the sub part of the other topic called time and work, and the topic name is pipes and cisterns. We will see what is the main difference between the pipes and cisterns when compared to the time and work. See, in time and work, when we are discussing with the time and work, there were people and they used to complete the work. In time and work, people were there who used to complete the work, but when it comes to pipes and cisterns, in the place of people you will have pipes, and in the place of work you will have the tanks. See, for time and work, if I form an equation, for example, let two people completes a work in 10 days. If I say this in time and work, in pipes and cisterns the same sentence can be written as two pipes can fill a tank in 10 minutes. That is what we can say. See, in time and work you will have people, they will be completing the work, but when it comes to pipes and cisterns you will have the pipes in the place of people and they will be filling the tank. I written an example for time and work. If I say two people can complete your work in 10 days, then for the same thing for pipes and cisterns I can say that two pipes can fill a tank in 10 minutes. Let us take a small diagram, you will understand what this is all about. See, whenever we speak about the tank, there will be pipes which will be filling the tank and there will be a pipe which will be emptying the tank. For example, when we clean the tank, the drainage water should go from the tank through a pipe that is called as the outlet or the waste pipe or the pipe which will remove the water. Now check this. Let us understand with a rough diagram, small diagram. Think this is water. This thing, think this is pipe A which is filling the tank and pipe B also filling the tank. Pipe A and B are filling the tank, and consider this is pipe C which is emptying the tank. That means which is removing the water from the tank. In this diagram, A and B are the pipes which are filling the water, C is the pipe which is removing the water from the tank. Now check this A and B which are filling, the pipes which are filling the tank, they will be always considered as positive values. This is filling pipes. A and B, both the pipes are filling the tank, so that we can consider A and B as positive value in calculation. But the pipe which is removing the water, I will write it as the waste pipe. The waste pipe which is C, it is removing the water from the tank, which is emptying the tank. So, whenever you are doing the calculations, the waste pipe or the drainage pipe should be taken in negative values. Remember this, when you see the questions we will understand, but remember the pipes which are filling the tank should be taken in positive and the pipes which are removing the water from the tank should be taken in negative. And the remaining way of solving the questions will remain same. How we solve the questions from time and work, the same way we are going to solve the questions from pipes and cisterns. As I said, in the place of people we will have pipes here, in the place of people you will have pipes, and in the place of work there will be tanks. The people will be doing the work and the pipes will be filling the tanks. We will see the questions on this, then the concepts will get cleared. See the question, two pipes takes 30 minutes and 45 minutes respectively to fill the tank. Find in how much time the tank will be filled. Two pipes takes 30 minutes and 45 minutes respectively to fill the tank. Find in how much time the tank will be filled if they open together. I will write that line here, if they opened together, if they were opened together, opened together. This is the question. The question says two pipes will take 30 minutes and 45 minutes respectively to fill the tank. Find in how much time the tank will be filled if they were opened together. See, the same question we have seen in time and work as two people takes 30 days and 45 days to complete the work. If they work, that is respectively, that means one person will complete the work in 30 days, another person will complete the work in 45 days respectively. If they work together, in how many days they will complete the work. So, similarly here also, one pipe is filling the tank in 30 minutes, another pipe is filling the tank in 45 minutes. So, if both the pipes are opened together, in how much time the tank will be filled. Let us see, we will see the general method what we used in time and work, how we solved it. See, I will write here this as the traditional method. The traditional method we will see the total time is nothing but find out in 1 minute how much tank, how much capacity the first pipe will fill, and in 1 minute how much part the second pipe will fill. See here, I will write it the total time for to get the tank filled. First I will convert this times of each pipe into 1 minute part. So, A will fill 1 minute part, I will write here, take two pipes as A and B, one pipe is A, another pipe is B, I am taking it as 1 minute. So, 1 minute part of A is 1 by 30 plus 1 minute part of B is 1 by 45. Then if you take the LCM, this 30 plus 45, 75 by 30 into 45. This is 15 5s are 15 3s are 3 1s are 5 1s are 5 6 are 15 5s are 15 3s are 5 1s are 5 6 are, which is 1 by 18 part. So, if both the pipes are opened together they will fill 1 by 18th part in 1 minute. So, the total time required. So, the total time required is reciprocal of 1 minute part is the total time. There we have written reciprocal of 1 day work is nothing but total days. Here reciprocal of 1 minute part is total minutes taken. So, that is 1 by 18 is 1 minute part, that means total time will be 18 minutes of the time they will take. This is one method of solving the question. Or we can solve the question in another way where we can directly use the formula. Or let us write it here itself, or the total time is the time taken by the first pipe, the time taken by the second pipe by both the times you add it. So, that is first pipe is 30 minutes, second pipe is 45 minutes, together 30 plus 45, right, we will write it here 30 into 45. So, it is 30 into 45 by 30 plus 45 is 75. So, this is 15 3s are 45, 15 5s are 75, 5 1s are 5 6s are. So, 6 3s are 18 minutes. This is the total time required by both the pipes together to fill the tank. See, let us see the other method to solve the same question. There are n number of methods we can find to solve these questions. See, we have seen this method in time and work also, where take out the LCM of both the things, right. So, the total units or the total capacity are take it as total. So, the total you take it as LCM of 30 comma 45, which is 90 units, take it as 90 units. So, take it as 90 units, 33s are 45 2s are 90, take it as 90 units. Now, see the total time required. The total time required, So, total time required for both the pipes together to fill the tank is LCM, the total capacity is 90 units by first pipe will take total 30 minutes, that means 30 into 3, for every minute it will send 3 units, and the second pipe takes total 45 minutes. So, for every minute it will take 2 units. So, it will be, simplify it, which will be 90 divided by 5, which is 18 minutes. So, there are n number of methods we can solve. See, first we use a traditional method where we converted the individual times into 1 minute. So, A 1 minute part is 1 by 30, B 1 minute part is 1 by 45. Then we calculated if A and B works together, what is the part that will get filled in 1 minute. So, after finding that reciprocal of it, that means reverse of 1 minute part will give the total time, that is in 18 minutes it will fill. Or you can use the formula first pipe into second pipe by first pipe plus second pipe, where we used in time and work x into y by x plus y, same thing. So, the second thing, the last method is take the LCM to find out the total units of the work or total units of the tank. So, then take the LCM of this by taking 30 minutes of the first pipe into 3 is 90, 45 minutes by the second pipe into 2 is 90. So, 90 by 5, that is 18 minutes. See the question. Two pipes A and B can fill a cistern in 20 minutes and 30 minutes respectively. There are two pipes, they are taking 20 minutes and 30 minutes respectively to fill a tank, and a third pipe C can empty it in 40 minutes. So, here two pipes are there which are filling the tank, and the third pipe is there which is emptying the tanks. That means the third pipe is removing the water from the tank. How long will it take to fill the cisterns if all the three pipes are open together? If all the three pipes are open together, in how much time the tank will be filled? Let us see the methods. So, the solution is written as, you will use the traditional method one more time. See, A plus B, the pipes A plus B, these two pipes are filling the tank, and pipe C is emptying the tank. So, keep minus symbol. So, in 1 minute how much part they will fill? In 1 minute how much part they will fill? See, A and B are the pipe which are filling the tank. So, I taken them as positive, and C is the pipe which is emptying this tank. So, take it as negative. We have seen in the notes, whenever a pipe is removing the water, take it in negative terms. So, pipe A will take total 20 minutes. So, in 1 minute it will fill a part of 1 by 20. Pipe B is taking total 30 minutes, in 1 minute it will fill a part of 1 by 30. So, pipe B is taking total 30 minutes, in 1 minute it will fill a part of 1 by 30, and pipe C is taking total 40 minutes to empty the tank. So, in 1 minute it will remove 1 by 40th part of the water from the tank. Now, take the LCM by taking, I will take 1 by 10 as the common, then we will have 1 by 2 plus 1 by 3 plus 1 by 4, we will write it. 1 by 2 plus 1 by 3 minus 1 by 4, this is 1 by 10 into, take the LCM of this. So, this is 2, leave 2 and multiply 3 4s are 12, plus leave 3 and multiply 2 4s are 8, minus leave 4 and multiply 2 3s are 6 by 2 into 3 into 4. I will write here. So, this is 1 by 10 into 12 plus 8, 20 minus 6, that is 14 by 2 into 3 into 4. So, 12 minus 6 is 6 plus 8 14, or 8 minus 6 2, 12 plus 2 is 14, anything. So, this is 2 1s are 2 7s are, this is 2 1s are 2 7s are, which is 7 by 3 4s are 12 into 10 is 7 by 1/20th part in 1 minute. In 1 minute it will fill a part of 7 by 120. Now, the time required. So, the time required is reciprocal of 1 minute part. So, the time required is reciprocal of 1 minute part, that is 120 by 7. So, this is 120 by 7. If we calculated it, see 7 1s are 7, you will have another 5, 7 7s are. So, 17 3 by 7 minutes. When two pipes are working which are filling the tank, and another pipe is working which is emptying the tank, when all the three pipes are open together, the tank will be filled in 17 3 by 7 minutes. 17 7s are 119. So, it is 120 by 7, which is 17 1 by 7 minutes. So, 17 7s are 119 plus 1 120, that is the total time taken by all the three pipes to fill the tank is 17 1 by 7. Actually, here three pipes are working, but only two pipes are filling the tank, and the third pipe is removing the water from the tank. This is a method. Or let us see the other method to solve the question. Now see the total capacity, consider the total capacity of the tank is LCM of 20, 30 and 40. So this is for 40, 30 and 20, the lowest common number in the tables is 120. So it is 120 because 20, 40, 60, 70, 80, 90, 100 won't come together in all the three tables, only 120 will come. So think it as 120 units. Okay. Now the total time is given as total time to fill. I will write here R, that means you can solve the question in another way. So total time to fill the tank is 120 is the total capacity by, see here, first pipe takes total 20 minutes to fill the tank. So every minute it will send 6 units, 120 by 20 is 6 units. So let me write 6 here. And the second pipe takes total 30 minutes, that means 1 minute, 120 by 30, that is 4 minutes, that means 4 units every minute it will send. These two are filling the tank, so take them as positive, minus the third pipe is emptying, it will take 40 minutes to empty, so 43 is a 120. So it is 120 by 6 plus 4, 10 minus 3, 7. So 120 by 7 is 17, 1 by 7 minutes for the tank to be filled. So when all the 3 pipes are open together, in which 2 pipes are filling the tank and when 2 pipes are emptying the tank, so they will take total 17, 1 by 7 minutes for the tank to be filled in this case. The question says, a cistern has a leak which would empty the cistern in 20 minutes. Leak means it is a drainage pipe or a waste pipe. It will empty already filled tank in 20 minutes. A tap is turned on which admits 4 liters a minute into the cisterns. So one pipe is removing the water from the tank. So if the tank is full, the pipe will empty the tank in 20 minutes. So there is another pipe which is opened that will fill the tank. So he says that this pipe which is filling the tank will fill 4 liters of water every minute into the cistern or the tank, and it is emptied in 24 minutes. When both these pipes are opened together, the tank will be emptied in 24 minutes. How many liters does the cistern hold? That means this question can be asked, how many liters are the volume of the tank? So this question can be asked, how many liters are the volume of the tank or the capacity of the tank? Anyway the question can be asked. So first we will find out in how much time this pipe, the second pipe will fill the tank. He did not give complete time, he just said it will send 4 liters of water every minute into the tank, but he did not give total how much time it will take. Let us see, we will take it here, let the filling pipe, I am writing, let the filling pipe takes, let us see some p minutes. Consider the filling pipe take p minutes to fill the tank. Now see here, we can use any method. See here, if we go for the method, we need to find out first the filling pipe takes how much time to fill the tank completely which is empty. That is the motto, that is what we are going to find out. See 1 minute part of it is 1 by p minus, why minus, one pipe is emptying the tank, so it will empty the tank in 20 minutes. So in 1 minute it will empty 1 by 20 is equals to. Now see the total part also given in emptied method only, that means he is speaking about emptiness only. So take that as minus 1 by 24. So in 1 minute minus, in 1 minute 1 by 24th of the part will get emptied. So now check it here, this is, so here we will write 1 by p is equals to minus 1 by 24 plus 1 by 20. So this is 4 by 20 into 24, this is 4 ones are 4 6 are, this is 1 by 120, therefore p is equals to 120 minutes. But what is p? P is nothing but the time taken by the filling pipe to fill the tank completely. So P is the time required to fill the tank, right here, to fill the tank. Now see, he has given the pipe which is filling the tank will send 4 liters of water every minute into the tank. So, the capacity of the tank or the volume of the tank or the liters, the number of liters that the cistern or the tank will hold. So, the capacity of tank or cistern or anything is okay. Capacity of cistern I will write. See here, in 1 minute, it will send 4 liters of water. The pipe which is filling that cistern will send 4 liters of water in 1 minute, but it will fill the tank completely in 120 minutes. So, what is the amount of water that will go into the tank in 120 minutes? That will be nothing but the capacity of the tank. Listen that clearly, in 1 minute it will send 4 liters of water into the tank, and it will take total 120 minutes to fill the tank completely. So, in this 120 minutes, what is the amount of the water that will go into the tank? That will be nothing but the capacity of the tank. So, 120 minutes is nothing but 120 into 4, that is 480 liters is the capacity of the tank. So, 480 liters is the capacity of the tank. We did not do anything here, we just find out the total time taken by the pipe to fill the tank. The total time taken by the pipe to fill the tank, we just found out that, and finally we get the answer. So, compare that, in 1 minute if it send 4 liters of water, in 120 minutes it will send 120 into 4, that means 480 liters is the capacity of the tank. The question says, 2 taps can separately fill a cistern in 10 minutes and 15 minutes respectively, and when the waste pipe is opened, they can together fill it in 18 minutes. The waste pipe can empty the full cistern in. This is same kind of question, but little bit information he turned here and there. Let us see that. Right, the question says, the waste pipe can empty the full cistern in how much time? Let the waste pipe takes, let's write it some value, I will take it as p minutes. The waste pipe takes p minutes I am considering to empty the tank. Now check here, the first pipe will fill the tank in 10 minutes, means 1 minute part is 1 by 10, plus the second pipe will fill the tank in 15 minutes, 1 minute part is 1 by 15 minus 1 by p, because for the third pipe or the waste pipe we do not have a time, for we just assumed something as the time required to empty the tank completely, which is p minutes. When all the 3 pipes are open together, the tank will get filled in 18 minutes, that means in 1 minute it will fill a part of 1 by 18. In 1 minute it will fill a part of 1 by 18. So, this is 25 by 10 into 15 minus 1 by p is equals to 1 by 18. So, this is 5 2s are 5 5s are 5 1s are 5 3s are. I will take this minus 1 by p to that side, it is 1 by p is equals to, take this 1 by 18 to this side. So, which is 1 by 6 minus 1 by 18, 18 minus 6 is 12 by 6 into 18, 6 1s are 6 2s are 2 1s are 2 9s are. So, this is p is equals to 9 minutes. For what this 9 minutes is required? 9 minutes to empty the tank completely. This is what we will consider for the tank to get emptied by the waste pipe. So, take this, see the question clearly says there are 2 pipes which are filling the tank, he has given the times, and he is asking there is a pipe which is emptying the tank. So, when all the 3 pipes are opened at a time, the tank will be filled in 18 minutes. So, take everything in positive except that assumed value which is emptying the tank. So, take it as negative minus 1 by p. So, take the LCM of 10 and 15. So, that is 25 1s are 25, 6s are 150, minus 1 by p is equals to 18. So, 18 you take that side, 1 by 6 minus 1 by 18, that is 18 minus 6 is 12 by 6 into 18. So, 6 1s are 6 2s are 2 1s are 2 9s are. So, the waste pipe takes total 9 minutes to empty the tank completely. Right, we will see the same question in a different method. See the question what we solved, 2 taps can separately fill a cistern in 10 minutes and 15 minutes respectively, and when the waste pipe is open, they can together fill it in 18 minutes. The waste pipe can empty the cistern in. See, the question is clear. The question says there are two pipes which are filling the tank, and there is an pipe which is removing the water, which is called as waste pipe. See, we have seen the traditional method to solve the question. Let us see the other method to solve this. Take the LCM of all the things, which is the capacity of the tank. Consider it is capacity of the tank. The LCM of this 10, 10, comma 15, comma 18 is 90 units. Consider it as 90 units. That is the LCM of 10, 15 and 90. 18 5s are 90, 15 6s are 90, 10 9s are 90. Now, the time taken by the waste pipe to empty the cistern, I will write here required time. The required time by the waste pipe to empty the cistern, we are not writing that, just listen. The required time by the waste pipe to empty the completely filled cistern is, the total quantity is 90 units. By the first pipe will take total 15 minutes, I am sorry 10 minutes to fill the tank. So, 10 9s are 90, plus the second pipe will take total 15 minutes to fill the tank, 15 6s are 90, and the last pipe takes total 18 minutes to empty the tank, 18 5s are 90. So, we are taking the LCM of the values. So, it is 90 by 9 plus 6 is 15 minus 5 is 10. So, zeros will cancel, it will be 9 minutes. So, if the tank is completely full, then the waste pipe will take total 9 minutes to empty the tank. The waste pipe takes total 9 minutes to empty the tank. The question says, a cistern can be filled by a tap in 4 hours, while it can be emptied by another tap in 9 hours. So, there are two taps for a cistern. One tap is filling the tank and another tap is emptying the water from the tank. So, the pipe which is filling the tank takes total 4 hours to fill the tank, and the pipe which is removing the water from the tank takes total 9 hours to empty the tank. If both the taps are opened simultaneously, then after how much time will the cistern get filled? After how much time will the cistern get filled? The time required is, this is x into y by x plus y. I mean, we can take first pipe into second pipe by first pipe minus second pipe, or second pipe minus first pipe, anything, because what is the highest value? Subtract the lower value from this highest value. So, this is 4 into 9 by 9 minus 4. So, this is 36 by 5, which is 7.2 hours. So, the question says, if they are open together, if they are open simultaneously, the tank will be filled in 7.2 hours. Or the question can be solved. The question can be solved as, take the LCM again. So, the LCM of 4 comma 9, 9 to the 18, 9 is 27, 9 4s are 36, 4 9s are 36, which is 36 units. This is the LCM of both the things. So, the time required is, total capacity is 36 units. So, always write the highest values first. See, the pipe is taking total 4 minutes. A cistern can be filled by a tap in 4 hours. So, 36 is the total units, 4 9s are 36, minus, why minus? Because the other tap is emptying the tank. So, 9 hours, every hour 9 4s are 36. So, it is 36 by 9 minus 4. So, it is 36 by 9 minus 4 is 5, which is 7.2 hours. This is the time required. Or we can also solve the question by taking the traditional method, that is called 1 minute part of both the pipes. I will just write here. So, 1 minute part of both the pipes open together is 1 by 4 minus 1 by 9, which is 5 by 36. This is 1 minute part. In 1 minute, this is a part that will get filled. So, the time, total time required time, we can say, which is 36 by 5 which is 7.2 hours are required. 7.2 hours are required. For what this 7.2 hours are required? If both the taps are opened simultaneously, then after how much time will the cistern get filled? The cistern will be filled after 7.2 hours when these two pipes are opened together. The question says, two pipes A and B can separately fill a tank in 12 minutes and 15 minutes respectively. They both will fill a cistern in 12 minutes and 15 minutes respectively. Both the pipes are opened together, but 4 minutes later, the pipe A is turned off. So, the first pipe is stopped working after 4 minutes. Now, the question is, how much time will it take to fill the tank? So, in how much time, in total how much time the tank will be filled? Rather than using the methods which we already used, let us see equation method to solve this question. Let us see an equation method. See, A is taking 12 minutes, I will just write here, A is taking 12 minutes and B is taking total 15 minutes to fill the tank separately. If A is alone, the pipe A only there, then it will fill the tank in 12 minutes. If only pipe B is there, it will fill the tank in 15 minutes. Okay. These both the pipes are started working together, that means A plus B are started working together, that means both the pipes were opened together, that means they were opened for 4 minutes. So, 4 minutes. So, both pipes were opened for 4 minutes. So, 4 minutes part of A plus B and A and B plus I do not know still how much time required. Let us take here extra time required or time required now. Extra time or after removing this pipe A or after closing the pipe A, what is the time required? I am just taking the time required, let us take it as some P minutes. So, 4 minutes part of A and B together. See, after 4 minutes A is closed, means still B is running. So, let us take B will fill the tank in P minutes. Fill the tank means remaining tank. So, the remaining part of the tank will be filled by B in P minutes. So, the work is 1. This is what we have seen in time and work. So, 4 into A 1 minute part is 1 by 12 plus B 1 minute part is 1 by 15 plus P into 1 by 15 is equals to 1. So, this is 4 into 12 plus 15 is 27 by 12 into 15 plus P by 15 is equals to 1. So, this is cancel it, 3 9s are, 3 4s are, 3 3s are, 3 5s are. Now, this is 4 1s are, 4 1s are. This is P by 15 is equals to 1 minus 3 by 5, which is 2 by 5. This is 5 1s are, 5 3s are. Therefore, P is equals to 3 into 2, that is 6 minutes to fill the remaining part. For remaining part, that we will write for remaining part. So, the pipe B alone will fills the remaining part for 6 minutes. Now, the question he asked is, what is the total time required? The total time required is, first A and B worked for 4 minutes. Now, the total time required, total time is, first A and B worked for 4 minutes and later after 4 minutes A is closed and B alone worked for another 6 minutes to fill the tank, that means the remaining part. So, the total time required is 4 minutes plus 6 minutes, that is 10 minutes. So, the tank will be filled in 10 minutes totally, even though the pipe A is closed after 4 minutes of working together. This is a will take. The question says, in the process of filling a tank, a pipe works 3 times faster than the second pipe. If both the pipes are opened together, the tank will be filled in 156 minutes. Find in how much time the slower pipe alone can fill the tank. find in how much time the slower pipe alone can fill the tank. That is what he says. See, let's the first pipe, let's take the first pipe is taking total p minutes to fill the tank. See here in the question he says one pipe is working 3 times faster than the other pipe. That means the efficiency of first pipe is 3 times than the other pipe. So definitely the second pipe will take, as per this, the second pipe will take 3p minutes. That means the time should taken by both the pipes should be like that. One pipe should be 3 times efficient. That means it will take 3 times less time than the other pipe. See, if in this case, if you take p value as 10 minutes, the first pipe will fill the tank in 10 minutes and the second pipe will fill the tank in 30 minutes, which is 3 times more than the first pipe. When both these pipes are opened together, when they are opened together, that means 1 by p plus 1 by 3p. The tank will be filled in 156 minutes. That means in 1 minute 1 by 156 is the part that will be filled. So 1 minute part of the first pipe is p and 1 minute part of the second pipe is 1 by 3p is equals to, in 1 minute the part will be filled is 1 by 156. Now this is, take this p 1 by p as common, this is 3 plus 1, 4 by 3 is equals to 1 by 156. So this is 3 ones are 3 5s are 15, 3 2s are 6. Now what we left with, 4 by p is equals 1 by 52. So the value of p is, 52 into 4. So 52 into 4 is 208 minutes. But from these assumptions we can say the pipe which is taking less time will be the faster pipe and the pipe which is taking more time will be the slower pipe. We told we discussed already, the efficiency will be inversely proportional to the time taken. If more is the efficient, less is the time taken. If less is the efficient, more is the time taken. Now p is 208 minutes, which is the faster pipe will take. Now the slower pipe will take. So the slower pipe takes 3 into p, that is 3 into 208 minutes, which is, so 3 into 208 minutes. So 3 8s are 24, 3 2s are 6. So 624 minutes is the time that is required. The question says, find in how much time the slower pipe alone can fill the tank. See, in these two pipes, one pipe is slower and another pipe is definitely faster, or the question can be solved as, see this part I will consider again. So first pipe will take p minutes, second pipe will take 3p minutes. So x into y, or first pipe into second pipe by first pipe plus second pipe, and the time taken is 156, and the time taken is 156. So it is p into 3p by 4p is equals to 156. Here p and p will cancel, 3 1s are 3 5s are 15, 3 2s are 6, 3 5s are 15 and 3 2s are 6. Therefore p is equals to 4 into, so the value of p is equals to 4 into 52, which is 208 minutes you consider. So this is faster pipe. So 208 minutes is the time taken by the faster pipe. So we need slower pipe. So the slower pipe is, that is 3p. So 3 into p, which is 3 into 208, that is, this is p and a. So this is 624 minutes. So it will take a total of 624 minutes of time that will be required by the slower pipe alone to fill the tank. Okay. This is the process we will use to solve this type of questions. See this question, a tank will be filled by two pipes in 24 minutes and 32 minutes respectively. So there are two pipes, they will take 24 minutes, I mean one pipe will take 24 minutes, another pipe will take 32 minutes to fill the tank. If both the pipes are open together, then after how much time should the second pipe should be closed so that the tank will be filled in 18 minutes. So here is a case that after they both are open together, after how much time this second pipe should be closed so that the tank will be filled exactly in 18 minutes. Now let us see how to solve this type of questions. So the solution is nothing but, Take first the capacity of the tank. So, the LCM is 24 comma 32, which is 96 units. So, total capacity is 96 units. See the first pipe. The first pipe will take total 24 minutes to fill the tank. That means in 1 minute, 96 by 24, that means 4 units per each minute, per minute. So, the first pipe will send 4 units of water into the tank for every 1 minute. Now, see the second pipe. So, 96 by the second pipe is 32. So, 96 by 32, 32 ones are 32 threes are, that is 3 units per minute. That means the second pipe will send 3 units of water for every 1 minute into the tank. Now, see the question clearly. Both the pipes are open together, then after how much time should the second pipe should be closed? Only second pipe should be closed and the tank will fill in 18 minutes. That means the first pipe will work for all the 18 minutes. So, here only I will write. So, 1 minute is 4 units means 18 minutes. In 18 minutes, 18 into 4, that means 72 units. So, the 72 units of the work or 72 units will be filled by first pipe. The first pipe will take care of all the 72 units. Now, what is the remaining thing? The remaining thing will be total 96. Out of this 96, 72 is filled. Now, so remaining is, I will write here only. Here I will see here. So, remaining. So, we will see the remaining. So, in this out of 96 units, 72 units were filled by the first pipe. So, remaining is 96 minus 72, that is 24 units will be filled by pipe B. As both are opened together, these 24 units will be filled by pipe B in. So, these 24 units will be filled by pipe B in. 24 is remaining units and pipe B will send 3 units of water for every 1 minute. So, 1 minute is 3 units. So, this 24 units is 3 ones are 3, 8s are, that means 8 minutes. So, the 24 units will be filled by the pipe B in 8 minutes. Therefore, pipe B should be or pipe B or pipe first pipe or second pipe, anything. I took it as pipe B, which is the second pipe, anything is okay, consider it as second pipe. So, pipe B or second pipe should be closed. Second pipe should be closed after 8 minutes. So, the second pipe should be closed after 8 minutes, so that the tank will be filled in 18 minutes.